escalating quickly with the idea. Now, in this case, the expression has changed drastically. Something is in the denominator. But now I have a new idea in my mind. All I want to know is whether the overall expression is positive or negative, and where is it positive or negative, right? So again, I want the same story. I want it greater than 0. Roots are still going to be 3, 5 and 7. Let's consider those numbers and see what happens. I go any number beyond 7, say 8. 8 minus 7, positive number, positive number, positive number. So on this side of the story, I will still get a positive result. And I want it greater than 0. So answer wise, I will say x is greater than 7 is still going to work for me. What will happen between 5 and 7? If I put 6 in the story, this will become negative. The other two will be positive. The overall result will be negative. I don't want negative, so I will ignore this region. What happens, and I'm just following the same logic now, and you can check it again and understand that bringing an expression down from the numerator to the denominator is not making too much of the difference in the polarity in terms of the overall result, whether it's positive or negative. Check for yourself, put 4 here. 4 is bigger than this, so you get a positive. You get a positive. And 4 minus 5, you get a negative. 4 minus 7, you get a negative. Negative gets cancelled and you get a positive number overall. Go less than 3 and again you will see it is becoming negative. So again, I wanted the positive region, so I would say my answer is also x is greater than 3, less than 5. Right, so part 1 is very easy. It's exactly like the previous problem. Same idea. The graph might look different, but overall, if I'm thinking of positive, negative, exactly the same logic. Spot the roots and then play accordingly. Now, the tricky part, or again where you have to pay extra attention, is if I put the sign equal to 0, where will the changes happen? Let's see. Can I make x is equal to 3? Because right now it is not, it is greater than 3. If I put x is equal to 3, this becomes 0. Overall, this will become 0. Whatever this is, it doesn't make a difference. My expression will become equal to 0. So, x is equal to 3 is okay. It works for me. Check for 5 as well and you will see that also works. 5 minus 5 is 0. 0 into 0, something is 0. And 5 minus 7 will give you minus 2. But 0 divided by minus 2 will give you a 0. So, 5 is also okay. So, I am making it equal to 5 as well. Just like I made it equal to 3. But can I make it equal to 7? I cannot, because if I make it equal to 7, 7 minus 7, there will be a denominator in the 0, which is problematic, right? I do not know how to operate with a denominator in the 0. So because of that, even if there is an equal sign here, this is fine, you should add it to the answer, but this is not fine, this will remain the same. What is the summary? That means where do you have to pay extra attention? If being equal to 0 is allowed, I have to pay extra attention to the denominator, and I do not want the denominator to become 0, because then the whole expression will be problematic, right? So again notice how quickly we have reached into cubic expressions and fairly complicated looking things, but once we figure out the basic idea, it is going fairly quickly. Then it becomes a matter of concentration again. Am I paying attention to the minute details? The broad logic is already in place. So for any question that I am posting here with a greater than 0, on your own also think of less than 0, greater than equal to 0, less than equal to 0 for your own extra benefit, right? So easy enough expression, we already know the logic. I'm just playing with the basic data over and over again to make sure that we have enough practice as well. We have the idea in place, now we throw in the practice, right? What are the roots going to be? When does this become 0? And forget that it's in the denominator right now. Just find out where the root is going to be. At minus 2, this part becomes 0. So minus 2 is a root in the story. And at 3, this becomes 0. I can guess that on right side of 3, everything will be positive. Between 2 and 3, everything will be negative. And beyond minus 2, everything will be positive. Check. 4 minus 3 positive, 4 plus 2 positive, positive by positive greater than 0, right? Not a problem at all. But if I say this is greater than equal to 0, that okay, let me forget the equal to sign. What would be the answer for this? I would say x is greater than 3 or x is less than minus 2, right? Any of these number ranges, right of 3, left of minus 2 is going to work for me. But if I now throw in an equal sign, what will change? I can make it equal to 3 because 3 minus 3 will be a 0. Overall, I'll get a 0, which is acceptable. But can I make it equal to minus 2? Why? If I put a minus 2 here, this becomes 0. Something upon 0, 1 by 0, it becomes problematic for me. So I will not add the equal sign and this will remain, and my new answer will change slightly. Right? So just a repetition with the idea that when you're dealing with the denominator and you're dealing with the equal to sign, be a little extra careful. So now it is just twists and turns in the language and how the information appears. And that is why the extra effort in just polynomial manipulation, factorization, multiplication, etc. Because for my method to work, I need to know the factors, or I need to know where those root points are. So this expression is not very useful for me. I need to factorize it. And what is the process? The process is start with a small number, try with a few numbers, see if you can get the whole expression to become 0 for a given value of x. So for example, if I try x is equal to 1, and let's see what happens. 1 cube is 1, minus 5 into 1 square will just be 1 minus 5. So 1 minus 5. And again there will be a minus 1 because x is equal to 1, and there will be a plus 5. So minus 5 plus 5 0, minus 1 plus 1 0. So at x is equal to 1, the whole function becomes 0. That means x minus 1 is a root, or that means x minus 1 is a factor and 1 is a root. If you do not know what we are talking about, go through the chapters on remainder theorem, factor theorem, and this will become very comfortable. So at 1 this becomes 0. That means this expression can be rewritten as, I know for sure that x minus 1 is a factor. Okay, what should it be multiplied with? I will leave this expression be. What should it be multiplied with to get this part of the story, right? And again, should be fairly easy to work out. X into what will give you x cube? So I know x into x square will give me an x cube. X into x square, x cube I will get. But I also have a minus 1. Minus 1 into an x square will give me a minus x square. But what do I want? I want a minus 5x square. I have a minus 5. That means I want minus 4x square extra. How will I get that? If I throw in a minus 4x here, x into minus 4x will give me a minus 4x square. So I'll add it in the story, and together this will become equal to this minus 5x square. But there is a minus 1 here. Minus 1 into a minus 4x will give me a plus 4x. But what I want in the story is a minus x. I have 4x, I have generated 4x, but what I want is a minus x. That means from 4x, if I subtract 5x, then I will get a minus x. That means I want a minus 5x. That means I should just throw a minus 5. X into a minus 5 will give me a minus 5x. And last step is always very easy. A minus 1 into a minus 5 will give me a plus 5. So I'm going for a very direct, practical, confident method of factorization. You can go slower, more systematically. Maybe in some other video we'll work out that process as well. But again, this is not the first time we are seeing this particular operation. So I'm assuming some experience even in the course itself has been provided here, right? So this is how it would work out for me. So the same story is now x minus 1 into x square minus 4x minus 5. Can I factorize this? This looks easy enough. X minus 5 into x plus 1. What is the idea? Think of the product, think of the sum. Think of two numbers, the product is minus 5 and the sum is minus 4. So minus 5 and plus 1 are such two numbers, and that's why the effort in the basic quadratic factorization in the beginning of the journey, right? So this step I'm assuming one way or another, whether from learning from earlier videos or from your school days, you're okay with this. If you're not, there are solutions available. There are more questions, more practice can be given on only this part. And that can be worked out, but you need to make sure that this is not challenging you psychologically at all. You know what the process is, right? Okay, so I get this and I want this to be equal to be less than equal to 0. The moment I reach this point, my life has become very, very easy. My roots are let me start with the lowest, minus 1, because minus 1 plus 1 will give you a 0, right? So minus 1, the next root is 1 and the next root is 5. Now it's very easy. On the right side of 5 is going to be positive. Between 1 and 5 it is going to be negative. Between minus 1 and 1 it is going to be positive, and less than minus 1 it is going to be negative, right? Now what is the question? The question is, I want it to be less than equal to 0. So let's just think of less than 0 first. Less than 0 is between 1 and 5. X is greater than 1 and x is less than 5. And where else? It is below x minus 1. Now I also want equal to 0. They're all in the numerator, so I can make all of them equal to each other. Or I can hit the root points as well, because they will become 0. 5 if I put here, this becomes 0, everything becomes 0. No mathematical law is being broken. So things we have seen earlier and things that we might have learned in other places, how to factorize, right? So in such a scenario, that whole art of multiplication and factorization and mostly being comfortable with it becomes very, very important.